Professor, Physician, Epidemiologist. I am Dr. Sri Banerjee. Hello, I'm Dr. Sri Banerjee, Dr. B, and in this video I'll be going over how to complete complex samples logistic regression in SPSS. So for starters, you have to create a CSS plan, and so CSS plan creation was done in another video. So here I'll be going over a little bit more about how to actually do a logistic regression. So again, here the regression, normal regression is up here under Analyze, and you can complete a binary logistic regression here. But for our purposes, because this is a nationally representative data set, National Health and Nutrition Examination Survey, we're more concerned with creating a logistic regression. So if we go into logistic regression and then make sure that the CSA plan is actually the plan that you are wanting to work on within the data set. And here, this is what we had named it. So hit continue, and then after hitting continue, we can then try out a model. So let's look for a research question. So stroke is a dependent variable that we could be asking about. So the presence of a stroke is actually the dependent variable that of interest, and then the factors that we're looking to look for predictors for is race, and then the covariate that we're looking to control for as the confounding variable is education level. So if we look at the education level, then this is actually a variable that we might be controlling for. So look at model, and then if we look at model, then if we look at the ethnicity and then the custom and then the main effects. So custom effects will show you the actual relationship between the dependent variable and the independent variable. So what you can do is you can actually build your model in this way and then provide include in model. And then you hit continue. And then if you look for these statistics, you can see that pseudo R squared is an important statistic to be thinking about when you're thinking about model diagnostics. So the question that you're wanting to ask once you build a model is how well is this model functioning in relationship to another model? In other words, how well or how accurately is this predicting the dependent variable? So, that's one of many types of measures that you could be using. Another one is C statistic, which is a really important measure for this. Then you can take a look at some of the odds ratios that are assigned, and also units of change that you could be looking for. So then look for the save, and then um, options. Make sure that there's nothing you have to, and you can change anything you want here, but these can remain the same. And then you can hit OK. And so there's actually no values because of this variable. So let's take a look at this variable. And this is pretty typical. Sometimes the first time you run the model, there might be something that is not correct. So I think this variable may be one that doesn't really make as much sense in this situation, but inflammation is a known sort of predictor variable for strokes. So I'll be controlling for C-reactive protein, and maybe we can see if this model actually yields better results. So let's make sure that this is actually included within the model, and then we can then see if the model is run. So in fact, it did run this time, and so this was actually a good exercise because we're able to see now kind of how your output would look. So the population size, this is the weighted population size. So even though the valid number of individuals that are included within your analysis is 28,000, this is actually representative of 196 million people. So you are actually looking at the representation of 200 million people within this analysis. So that's a lot of people, and to be able to do that with this technique is quite powerful. So I hope I'm able to illustrate the importance of using something like this. This shows specifically how the odds ratio is in terms of ethnicity. So if we were to have five as the reference category, then in comparison to five, and you would actually go back and look what five represents. So if five is other, then one here would be a non-Hispanic white, two is non-Hispanic black, three is Hispanic, and then four, I believe, is Asian. So there's actually a comparison that you can make, and of course, this is after controlling for C-reactive protein. After you actually run the analysis, it's important to go back and see what all of this means. And I think what is really striking about this analysis is the ability to make a generalization about a significantly larger population than what you are studying within the analysis that you're that you're completing. So this is complex samples logistic regression. Thank you for listening.